Let's look at further integration of trig functions. So I'm looking at exercise 8.3. You can check in your textbook, but I copied down the examples for you in the order I would like us to analyze it. Based what I said in the previous lesson or the previous video, I said that every time we're going to be doing the integration of trig functions, I need to bring in the table with antiderivatives, and I must have the antiderivatives in front of me if I want to do it correctly. Look at the table, look at the example. So I have an integral which is cos of 2x times sine of 9x. Now if I look at my table here, I don't see any combination of cos of 2x and sine to the power of 9 or to the power of n, which means that I cannot use this table to answer my first question. It will be the combination of something else and my table. If it's something else, then I want you to think from now on that we are looking at multiplication of two terms. Multiplication of two terms. Obviously, the one with the power of 9 stand out more to us because of power of n, it's standing more out to us. So if I'm thinking about sine of 2x to the power of 9, how is cos of 2x related to it? Well, if this is sine of 2x on its own, let's say, so it's my function f, this is f dash, because it's a function of 2x and the derivative of this function of 2x. So I should be able to solve by inspection. If I have sine to the power of 9 of 2x, then I could start with sine to the power of 10 of 2x. Let's check what will this derivative be. Okay, let's remove the table. It's not going to be useful for us. Let's look at sine to the power of 10. So I have sine to the power of 10 of 2x, and I want to see what's going to happen if I differentiate this with respect to x. So what's the derivative? Well, the outermost function is 10, so it will be 10 sine to the power of 9 of 2x times inner derivative of sine is cos of 2x times inner derivative of 2x, which is 2. So if I differentiate sine of 2x to the power of 10, I actually get 20 sine to the power of 9 2x plus c. So what should be my answer for my integration? Well, obviously 1 over 20 to get rid of this coefficient, sine 10 of 2x plus c. If you are not very comfortable with this method, with inspection, you can try the substitution. So I can say, let the sine of 2x be equal to u. Then du dx is what? Cos of 2x times 2. So it will be derivative of sine is cos times the inner derivative. Now, how can I replace all of this in my first example? Right, so I will have an integral. Cos of 2x is now du dx times a half. Okay, that's from this step. cos of 2x will be a half du dx. What is sine of 2x to the power of 9? It will be u to the power of 9 times dx. Right, so dx with dx will simplify. You can take the constant out and you've got u to the power of 9 du. And then first algebraic approach, it will be half times u to the 9, so it will be u to the 10, 1 over 10 plus c. So I have 1 over 20. U was sine of 2x to the power of 10 plus c. Your choice, boys, whether you use the inspection or you use the u substitution. We do get exactly the same amount of marks, and that is 1, 2, 3, and 4 for this question. Stop it, clean the board, try to do it using your own method or the method that works for you. Next, we will look at example A. So example A, the integral of sine 2x times square root of 1 plus cos square of x dx. Like we looked at the previous slide, nothing like this is on my table of antiderivatives, so I need to figure it out by inspection, and I need to first look at which of the two functions is my core function, which one brings my attention. Well, my attention always goes to the bracket, to the square root, because square root is the same as a bracket to the power of half. So I can say that in this integral, and I'm just ignoring the sine of 2x on the start, I'm looking at my bracket, cos square of x to the power of half dx, and I'm going to say that I'm taking an intelligent guess, and I'm saying that the answer to this integral must be my bracket, but to the power 1 up. So to the power of 3 over 2. So I'm guessing that this must be my answer. Now let me check how close to the answer I am with my guess. So the derivative will be 3 over 2 bracket to the power of half. So I'm there, okay, I've got my bracket to the power of half. But I have to have an inner derivative. Now inside the bracket you have a function cos to the power of 2. So the derivative will be 2 cos to the power of 1. Is that the end? No, it's not, because the derivative of cos is negative sine of x, which I cannot forget about. Which means that by inspection, I get that if I decide that my answer for my antidifferentiation is 1 plus cos square of x to the power of 3 over 2, then my integral should be minus 3 times sine x times cos x times the bracket to power half. Right, what I have? I've got my bracket. That's great. But I don't have this thing. I don't have a term sine x cos x times minus 3. But I have sine of 2x. Now, if I have sine of 2x, how can I turn this into a sine of 2x, that answer of mine? Well, sine x times cos x is sine of 2x. Okay, it's just that you need to get right coefficients, because as I'm expanding, this would give me 2, which I don't have, and this is minus 3. 1 plus cos square of x to the power of half. Right, not that easy. Think about it. Slow down, clear it, find your own ways of solving this problem. So that's my inspection. So what will be my final answer. Right, this coefficient is not here, so I want to get rid of it. Minus 2 over 3 times 1 plus cos square of x to the power of 3 over 2 plus c. Very complex. I do understand that it is complex because it's a combination of integration of trig function, differentiation of trig function, and all sorts of chain rules that we cannot forget about. Can we do it by u substitution? Well, let's try. If I say let u be equal to, now remember your u must always be your bracket. So it's 1 plus cos square of x. That will be my u. If I differentiate u with respect to x, I get then derivative of 1, 0. Derivative of cos square is 2 cos x times inner derivative, which is sine x. Okay, so I actually get this as sine of 2x. Let's replace everything. So I've got the integral sine of 2x. I replace with du dx times the bracket will be u to the power of half dx. Dx with a dx simplifies. What's the integral of u to the half? The integral of u to the half is u to 3 over 2 times 2 over 3, okay, plus c. Now you can see that the only problem I'm having is that I had a minus here and I lost the minus in there. Where did I lose it? Okay, I lost it in this step because the derivative of cos square is 2 cos and derivative of cos is negative sine of x. Okay, sorry for that. And now if we just substitute minus 2 over 3, u was 1 plus cos square of x to the power of 3 over 2 plus c. Your choice, boys, by inspection or by substitution. You choose which method works better for you. Stop it, redo it, make sure that you do not lose the minuses. Let's look at the next example.